Hi, good morning, friends. Happy Makar Sankranti to all of you, as well as Happy Lohri. Happy Makar Sankranti to all of you, as well as Happy Makar Sankranti to all of you. So, yesterday's class got disrupted due to the technical glitch. So, yesterday's class we will discuss the same thing, the problems on coagulation and flocculation, and then we'll move to the problems of filtration itself. So welcome to Just Get Civil. Welcome to Unacademy. Welcome to we are here for the Mission Gate 2021. We are actually in the verge of this examination. And when you're talking about Mission Gate 2021, we are actually going for a crash course on environmental engineering. Myself, Soumyajit Sen, is going to deal with this crash courses, and we have already done for 21 lectures. We're already done for this 21 lectures. Now we are entering the 22nd lecture. Then Unacademy, if just a reminder that if you don't have that Unacademy learning app in your mobile or in your device, go to the Play Store, type Unacademy learning app and install it right now. अभी इंस्टॉल कर लीजिए और देर मत कीजिए. It's better to start early and go for GATE and EAC and go for the plus course subscription. सब्सक्रिप्शन लेते वक्त आपको याद रखना है सिर्फ एक चीज दैट डोंट फॉरगेट टू अप्लाई द कोड SEN10 ACN10. Don't forget to apply the code SEN10 ACN10. If you apply it, you will get direct 10% of the discounts. Don't forget to apply the code SEN10 ACN10. We've already launched a batch for if GATE 2022 for civil batch A has started from 28th December. If you have not joined yet, join it today itself. And if you are getting subscription for the plus courses, where you will get the personalized mentorship, a coach will be assigned to you who has already gone through the process. तो आपको समझ में आएगा कि क्या कहानी क्या होता है, आपका स्ट्रेटेजी जो है उसको आप डिफाइन कर पाओगे सही ढंग से. And once again, don't forget to apply the code while taking the subscription, the SEN10. Don't forget to apply the code SEN10. Then already launched on 11th of January. We have launched two batches. One is for the two batches for both for this general studies for EAC prelims, and here also you can apply the code SEN10. Here also you can apply the code SEN10. Two batches that have been launched on 11th Jan. You can apply the code SEN10 for better discounts, for better pricing. Now we are going for the problems on coagulation and flocculation. So in the last few classes, we have already covered the theoretical segments of the environmental engineering, जिसका theoretical segment हमारा already हो चुके हैं. अब हमको करना क्या है, अभी जो बचा हुआ है, that is the problems and the recap of this process. We have started ये recap process हम लोग चालू कर चुके हैं. और जब हम theoretical segments पढ़ाई किए थे, तब domestic water supply part से already कुछ questions we have already solved. कुछ chapters का problems we have already solved, like water demand and population forecasting वाला chapter and sources of water वाला chapter का ये सब कुछ हो चुका था. अभी रिकैप में हम लोग क्वालिटी ऑफ वाटर एंड प्लेन सेडिमेंटेशन ये दोनों का प्रॉब्लम्स हम लोग कर चुके हैं। आज कोआगुलेशन, फ्लॉकुलेशन एंड फिल्ट्रेशन इन दोनों चैप्टर का प्रॉब्लम सॉल्व करेंगे। And tomorrow we will solve for this disinfection and a process of groundwater treatment. There will be a class on Saturday and Sunday where we will see that how to get secure 12 marks in just 6 hours. Those Saturday Sundays classes, if you do for those 6 hours, वो 6 घंटे में आपका 12 नंबर का सिक्योरिटी होगा, जिसका गारंटी मैं देता हूं। If you go through that 6-hour class, your 12 marks will be guaranteed. Don't miss that class on Saturday and Sunday, both 16 and 17. Don't miss the class. So before going to start the problems on coagulation and flocculation, we need to check that we need to just recap the thing कि क्या पढ़े थे हम coagulation flocculation में। एक्चुअली प्लेन सेडिमेंटेशन था जहां पे सस्पेंडेड पार्टिकल्स को लेके हम लोग काम किए थे और वो टाइप 1 सेटलिंग था। इसके सिवाय जो है वो है टाइप 2 सेटलिंग प्रोसेस कोआगुलेशन फ्लॉकुलेशन, जहां पे होता है where sedimentation along with coagulation flocculation is defined, और sedimentation along with coagulation flocculation when you are talking about, तो coagulation में क्या है कि कौन सा पार्टिकल्स के लिए हम देख रहे हैं, that is nothing but the colloidal particle, right? So when you're talking about the colloidal particle, size ranges in between 10 to the -3 to -5 millimeter in diameter. Correct. So when you're talking about the colloidal particle size, now apart from the colloidal particle, in some cases, some small amount of suspended particles will be also dealt with this process, but our major focus is the colloidal particle. And as the colloidal particle is having a protection with the electronic layers, to break those electronic layers, we have to apply a chemical from outside called as coagulant. That coagulant will destabilize the colloidal particle and then it will form small flock. So up to this it's called as coagulation. All those small flocks will attach with each other and they form bigger size flock. That is called as flocculation. And when they attain enough size and mass, they will get settled down. It will be called as the settlement or sedimentation. And type 2 settling process or flocculant settling will be observed. और हम लोग इसके सिवाय और भी कुछ देख चुके हैं कि व्हाट विल बी द डिफरेंट टाइप्स ऑफ कोआगुलेंट लाइक एलम, कॉपरस, उसका इक्वेशंस हम देख चुके हैं और हम आपको बोले भी हैं कि आपको इक्वेशंस याद रखना बहुत ही जरूरी है, अदरवाइज you won't be able to solve some problems. We will see those problems here also. And then what we have discussed that what will be the what will be the optimum dose of coagulant by conducting the jar test. What will be the optimum dose of coagulant by conducting the jar test? So these are the things which actually we are concerned about. The parameters, the design points we have already discussed. So now we are entering to the problem solving segment. First problem, grade 2003, very important problem. If you understand, if you can solve this problem, you are bang on target. to solve other problems of this type from coagulation flocculation. Read the question, take your time. Let's solve the question then. Let's solve the question then. So, sorry for this glitches. So, what is the question here? A water treatment plant is treating 10 mld of water, requires 20 milligram per liter of filter alum. The water has 6 milligram per liter of alkalinity as calcium carbonate. Molecular weight of aluminium, sulfur, oxygen, hydrogen, calcium, and carbon is given. First part, there is the two questions from one statement. Total alkalinity requirement in 10 to the power 6 milligram per day as calcium carbonate matching filter alum shall be, and the quantity of quick lime required 10 to the power 6 milligram per year as calcium oxide shall be. So what will be the procedure? What is given here? Q given how much? 10 mld, and alum required 20 milligram per liter. Alum 20 milligram per liter. So our first job is to write down the equation which is associated with alum. This is not provided, you need to know this. Remember this. I have told you separate time. Al2SO4 whole 3 dot 18H2O, that's alum, plus reacting with bicarbonate alkalinity mainly, providing that is the equation. So what is evident? 1 mole alum require 3 mole calcium bicarbonate. 1 mole alum required 3 mole calcium bicarbonate, right? तो भैया आपको पूछा क्या गया है क्वेश्चन में? टोटल alkalinity रिक्वायरमेंट एज कैल्शियम कार्बोनेट, लेकिन आपका रिश्ता किसके ऊपर हो रहा है? कैल्शियम बाइकार्बोनेट के हिसाब से। आपके पास कैल्शियम बाइकार्बोनेट का रिश्ता है, आपको निकालना है कैल्शियम कार्बोनेट। When you fall in this type of situation, you have to go for equivalency concept, and for going to this equivalency concept, करना क्या है आपको? आपको एक इक्वेशन तैयार करना है किसके बीच, जो दिया हुआ है और जो निकालना है आपको। So calcium bicarbonate is provided and calcium carbonate you need to find out. A balanced equation. So from the second equation, it is evident that 1 mole calcium bicarbonate is equivalent to 1 mole calcium carbonate. So we can say that 1 mole alum from this equivalency concept requires 3 mole calcium carbonate. If you solve for molecular weight of alum, it comes as 666, and the molecular weight of calcium carbonate will be 100. So we can say that 666 part alum required 3 into 100 part calcium carbonate, 1 part alum required 300 by 666 part calcium carbonate. कितना चाहिए alum का? 20 मिलीग्राम पर लीटर। 300 into 20 by 666, it's 9 milligram per liter of calcium carbonate. Correct? But they're asking in per day basis, right? So eventually what we need to do, total alkalinity required, nine milligram per liter. Q is 10 into 10 to the power 6 liter per day. that is 90 into 10 to the power 6 milligram per day. Now this whole is actually taken as a unit in this question. That's why it will be, the final answer will be only 90. Clear? Just have a look. Then we go for the second question, second part. That is A. Now the second part of this question. What is told? Quantity of quicklime required. अब अचानक से कैसे क्या हो गया क्विकलाइम? क्विकलाइम का मतलब क्या है? कैल्शियम ऑक्साइड. अचानक से इस सारे सिचुएशन में क्विकलाइम कहां आ गया? We need to identify that. So total alkalinity required 9 milligram per liter as calcium carbonate, right? The question, it is mentioned that water has 6 milligram per liter of alkalinity. Alkalinity already present. सिक्स मिलीग्राम पर लीटर एज कैल्शियम कार्बोनेट. तो कितना डालना है आपको? Alkalinity needs to be added. Now as they mentioning calcium oxide, इसका मतलब है they are putting not directly calcium carbonate, they are putting calcium oxide. So पहला ही है कि आपके पास कैल्शियम कार्बोनेट कितना चाहिए इसका हिसाब है, लेकिन आपका सोर्स क्या है? कैल्शियम ऑक्साइड. कुछ चीज आपके पास है, कुछ दूसरा चीज को निकालना है. सेम इक्विवेलेंसी कॉन्सेप्ट. क्या करना है? पहले कैल्शियम ऑक्साइड और कैल्शियम कार्बोनेट के बीच एक रिश्ता तैयार करना है. Equal. So it is evident that 1 mole calcium oxide can be provided, providing 1 mole calcium carbonate. So molecular weight of calcium oxide will be 56. So we can say that 100 parts of calcium carbonate will be provided by 56 part calcium oxide and how much it is? 3 milligram per liter. So total calcium oxide required 1.68 milligram per liter into 10 into 10 to the power 6 liter per day. It's milligram per day into 365 as they're asking in year. So it's 6132 into 10 to the power 6 milligram per year. So this 10 to the power 6 milligram per year is considered as the unit. So your final answer will be 6132. Check it out. Okay, let's go for the second question. Actually, it should be third question. So because previously I solved already two questions. Determine the quantity of alum required in order to treat 12 mld at a treatment plant where 14 ppm of alum dose is required. Also determine the amount of carbon dioxide gas released per liter of water treated. Solve this question. If you understood the question number 1 and 2, you can solve this very clearly. Solve this question. I'm giving you 2 minutes time. Solve this question. Let's solve it. So Q is 12 mld. Alum required 14 ppm. That is 14 milligram per liter. So what is required actually? So total alum required 12 into 14 mld into milligram per liter. Obviously it should be kg per day, right? 168 kg per day. So now they're asking what will be the amount of carbon dioxide gas release. Once again, you write down the equation. Al2SO4 dot 18H2O plus 3 calcium bicarbonate এখন কি করছিল 18H2O. So it's evident that 1 mole alum is releasing your 6 mole carbon dioxide. So once again, molecular weight of alum will be 666 and carbon dioxide is 44. So 666 part direct relationship is there, so no more equivalency concept. Release 6 into 44 part carbon dioxide. অল্প করে কফি ধুয়ে দিয়েছে কাজে কালকেরটা 1 part alum release your answer will be 5.55 milligram per liter. Okay, let's go for another question. Question number 3. At a water treatment plant, 12 mld is treated by using ferrous sulfate and lime. If the dosage of ferrous sulfate is 10 milligram per liter, then determine the quantity of ferrous sulfate and lime required. Luckily, they have given you the equation here. Get 2008 question. FeSO4 dot 7H2O plus calcium hydroxide FeOH2 plus calcium sulfate plus 7H2O. This equation is given. Now solve this question. Let's solve this question. Q is 12 mld. Ferrous sulfate dose is 10 milligram per liter. First, they're asking quantity of FeSO4 required. Very easy to solve. ml into milligram per liter. It is kg per day. Now, see what they're asking. They're asking to find out the quantity of calcium oxide required. But in this equation, it is shown that relationship of ferrous sulfate is with the calcium hydroxide. What you need to do? क्या करना है? Same equivalency concept कि हमको calcium oxide और calcium hydroxide के बीच एक रिश्ता तैयार करना है. So it's CaO. This thing you need to remember. This thing you need to understand. It's 1 mole. So eventually 1 mole ferrous sulfate is required for 1 mole calcium hydroxide, and 1 mole calcium oxide is equivalent to 1 mole calcium hydroxide. So you can say that required 1 mole calcium oxide. So here molecular weight of, we need to find out 56 plus 32 plus comes 278. So 278 part ferrous sulfate so 120 kg per day required. Directly it will be 24.17 kg per day. That is the final answer. Okay. Hope you understand this type. Now go for question number 4. A mixing unit of 2 meter cube with a velocity gradient equal to 600 second inverse. Fluid with absolute viscosity 1 in 10 to the minus 3 Newton second per meter square is continuously operated. What is the power input in watt? To solve this, so V is given as 2 meter cube. Velocity gradient capital G is given as 600 second inverse. Coefficient of absolute viscosity mu is given as 10 to the power minus 3 Newton second per meter square. Power input. What is G? Under root P by mu V. So from here, P is actually G squared into mu V. $720. Okay. Let's go for question number 5. A water treatment plant is required to process 28,800 meter cube per day of raw water. Density of water is 1000 kg per meter cube and coefficient of kinematic viscosity is 10 to the power minus 6 meters square per second. These values are provided. The rapid mixing unit produces a velocity gradient of 900 second inverse to blend 35 milligram per liter of alum. Detention time 2 minute. Power input in watt will be. Solve this question. Question number 5. FYI. Well, let's solve this question. So our water treatment plant is required to process 28,800 meter cube per day. So Q is provided as 28,800 meter cube per day. Density of water given as 1000 kg per meter cube. Asking power. So we know that G is equals to under root P by mu V. So power is actually G squared into mu V. The G value is given as 900 second inverse. Mu is not provided, it's nothing but nu into rho W. And V is also not provided. So what will be V? Nothing but Q into dt, detention time, that is provided. So 900 second inverse squared into 10 to the power minus 6 into 10 to the power 3 into Q is given as 28,800 meter cube per day by its detention time in minute. So 24 into 60 into 2. Your final answer should be 37,800. Sorry. 32,400. What? That will be your final answer. Hope it is clear to you. Now, going for the next question, question number 6. Design a flocculator for a design flow of 3000 meter cube per hour. Assume detention time as 20 minutes. G is 40 second inverse. Also determine the power requirement if mu is 1.0087 10 to the power minus 3 Newton second per meter square. L is to B ratio is 2:1 and height is considered as 0.4 B. Solve it. Let's solve this question again. So Q is given as 4,000, sorry, 3,000 meter cube per hour. So detention time provided as 20 minutes. So volume will be Q into dt, that is 3,000 meter cube per hour by 20 by 60. It's 1,000 meter cube. So volume is nothing but L into B into H. From here, 1,000 will be equals to L is to B, given ratio. So 2B into B into 0.4 B. So 0.8 B cube is equal to 1,000. So from here, B will be 10.77 meter. So from here, length will be 21.54 meter and height will be 4.3 meter. Okay. Now, also asking the power input. So power is actually G square into mu V. G square value 40 given. Mu value is also given. V is 1,000. Your final answer should be 1613.92 watt. Your final answer should be 1613.92 watt. Have a look. Looking for question number 7. The design parameter for flocculation is given by a dimensionless number GT. This is GATE 2004 question. the most preferred combination, the most preferred combination of G and T to produce smaller and denser flock. Option A, large G with short T. Option B, large G with long T. Option C, small g with short T. Option D, small g with long T. For smaller and denser flock. So for smaller and denser flock means here number density, smaller size flock, when you can produce smaller size flock only when you will go for a shorter T. Okay, detention time will be less, so lesser size of flock will be there. So quite obviously when size of the flock is less, so the GT value as it is a fixed, so G value should be large. So option A will be the correct answer. Option A will be the correct answer. Option A will be the correct answer. Large G with short T. Option A will be the correct answer. So that is the all the special type of problem from coagulation flocculation. Now we will go for the problems on filtration. We'll go for the problems on filtration. So filtration is the process where we're actually dealt with the dissolved solids. The size ranges in between 10 to the power minus 5 to minus 8 millimeter in diameter. It's an unit operation where no chemicals are being used from outside. It's nothing but a passing of water through a porous media, and the porous media is called as the filtered media, right? ये सब हम लोग ऑलरेडी जानते हैं. प्रॉब्लम्स ऑफ फिल्ट्रेशन जाने से पहले एक बार थोड़ा सा रिकैप कर लेते हैं सो दैट वी कैन रिमेंबर दोस थिंग्स, देन विल कम बैक टू द प्रॉब्लम्स ऑफ फिल्ट्रेशन इटसेल्फ. Just a recap of the slides where we have gone through the filtration process. What is filtration? It's nothing but the passing of water through the filter media, or porous media is called as the filtration. Then we have gone for the mechanism of filtration, where mechanical process, natural sedimentation, electrolytic action and biological action are the four process. We have discussed, हम सब कुछ सारे discuss कर चुके हैं. Just a recap we are going for. And what is dirty skin layer and smudge tech layer we have discussed also, right? उसके बाद हम लोग गए थे टाइप्स ऑफ फिल्टर, डिफरेंट टाइप्स ऑफ फिल्टर, ग्रेविटी फिल्टर, प्रेशर फिल्टर. Then we have gone for the rate of filtration part. Then we have gone for the discussion of flows and filter. Flows and filter are different components: filter box, filter media, gravel bed. What is gravel bed? What is the job of gravel bed? What is the thickness? Everything we have discussed. And then sand bed. और उसके बाद हम लोग कैसे उसका अंडर ड्रेनेज सिस्टम also we have discussed. Then we have gone for the discussion that how to clean a clean a source and filter. Where first, before going to that, we have discussed about initial head loss and the terminal head loss values. And we have discussed that the cleaning of source and filter is done by scratching or scraping process. Scratching or scraping process. Then we have gone for the rapid sand filter discussion. There we have seen that what are the ROF and efficiency varies in between. Then different components of rapid sand filter: filter box, filter media, gravel bed, under drainage system, and schematic of this rapid sand filter. We have discussed very clearly regarding the backwashing process, which is the cleaning process of rapid sand filter. Then operational procedure, which is very important to understand. Then we have gone for this design parameters. He is taking class. He will call you back after 11 a.m.
Hello?
बाईस तो So volume of water used in backwashing, then head loss during backwashing, equations, Karman-Kozny equation, very important to know, very important to remember the equation. Then head loss during backwashing, previously head loss during filtration and then backwashing, and equations are there supporting that head loss during the filtration process and backwashing process, that is JD by Z is equals to 1 minus N by 1 minus NE. Anything suffix E is actually related to the expansion process or backwashing process. Hope you remember that. And another equation, VB is equals to VS NE to the power 4.5, where VB is the rate of backwashing and VS is the settling velocity of sand particle. We have discussed the significance of the second equation and the relationship between the concentration of particle and the sand bed depth. Concentration of particle and the sand bed depth. And finally, we have gone for the Iwasaki equation. Iwasaki equation, filter constant we have discussed. We have gone for the Iwasaki equation. Certain operational problems of rapids and filter we have also discussed. Wait. Pressure filter, dual media filter, and multimedia filter. Okay, that was a recap. Again, I am going for the problems here. Problems on filtration. First, we will discuss about the certain theoretical questions and then go for the numericals. Solve this. So first 4 questions is enlisted here. Cleaning of slow sand filter is done by, very easy, it's 1A, scraping and removal of sand, scraping or scratching process. Question number 2, backwashing of rapid gravity filter may face rough weather due to its mud balls. We've discussed operational problem. Question number 3, air binding phenomena in rapid sand filters may occur due to excessive negative pressure. Then only air will be entrapped between the pores of the porous media or the sand particles. The quality of the filtered effluent and the working of the filter in a rapid gravity filter is adversely affected by. Question number 4. The quality of the filtered effluent and the working of filter in a rapid gravity filter is adversely affected by air binding here. Question number 5. A roughening of filter as used in treating water supplies is like a देखें ना मुझे देखिए rapid gravity filter with the coarser sand. 5C. Question number 6. Double filtration is used. Double filtration is first slow sand filtration, then rapid sand filtration. It is used, of course, to increase the filtration capacity of rapid sand filtration. 6B. Question number 7. In double filtration, the roughening filter unit is placed after the or prior to the slow sand filter. Rate of filtration in slow sand filter is in between 100 to 200 liter per hour per meter square. We have discussed already. So just I am writing here the double filtration concept. First rapid sand filtration, then slow sand filtration. Question number 9. The influent treated in rapid sand filter should generally be coagulated. Obviously, because pre-treatment and post-treatment both are required. Question number 9C. Question number 10. Pressure filters are used for, here generally it is used for commercial places like swimming pools. 10D. Question number 11. High bacterial removal by slow sand filter is accomplished by smudge deck. We have already discussed smudge deck layer. Question number 12. Consider mechanical staining, biological metabolism, electrolytic changes, and flocculation. The process of filtration are all 1, 2, 3, and 4. Question number 12. Let's go for question number 13. Pick out the incorrect statement for rapids and filter. The effective size of the sand particle D10. It's true. It's correct. The period of cleaning is usually 2 to 3 weeks. No. Once in a day or in 2 days. So question number 13B. Question number 13B. Question number 14. The uniformity coefficient of sand used in rapids and filter will be in between. कितना होगा 1.2 to 1.8. 14A. Question number 15. The effective size of sand particles used in slow sand filter is 0.25 to 0.35 mm. Question number 16. The periodicity with which rapids and filter need cleaning is usually 1 to 3 days. Option A, we have already discussed. Question number 17. The rate of filtration of pressure filter as compared to that of rapid gravity filter is obviously it will be better, bit higher. Question number 18. Cleaning of rapids and filter is done by backwashing process. Question number 19. As compared to rapids and filters, slow sand filters are. 4 options are provided. More efficient in removal of bacteria but less efficient in removal of color and turbidity. It's true. More efficient in the removal of bacteria as well as in the removal of color and turbidity. A and B is almost the same statement. Let's see. Less efficient, no. Less efficient, no. So which will be better? Efficient of slow sand filter is always higher than rapid sand filter. In any case, option B. Question number 20. Rapids and filter remove bacteria to as much as 80 to 90%. 20. Question number 21. As compared to slow sand filters, rapids and filters give in both the option A and B to return lower filtration rate, which is wrong. Option C will be the correct answer. Higher filtration rate but lower efficiency in removal of bacteria. Question number 22. The percentage of filtered water which is used to backwashing in rapids and filter is about 2 to 5%. The quality of filtered water, effluent or pressure filter, that of rapid gravity filter. Obviously, higher filtration rate will give you lesser efficiency, poor. Question number 24. In rapids and filters, the ratio of length to diameter of the lateral should not be exceeding 60. Question 25. All these questions are very important for your MCQ type process or for your job type interviews. Question number 25. Rapids and filter should be preceded by coagulation and sedimentation. Is used after slow sand filtration has been done. Uses rapid sand as filter media, can combine disinfection also. So question number 25A. Question number 26. Slow sand filter is efficient to remove the bacteria from the raw water to an extent of almost 100%. So it's 99% is the proper answer. Question 27. Rapid sand filter can remove bacteria up to 80 to 90%, lesser efficient than the slow sand filter. Question 28. The organic impurities top of filtering media, such a layer is called as dirty skin layer or smudge deck layer. 28C. Question 29. Let's see. Design 6 slow sand filter from the following data. Population 50,000. Per capita water demand is 150. LPCD. Rate of filtration 180 liter per hour meter square. L is to B 2 is to 1. And Q design is 1.8 of Q average. So obviously first we need to find out Q average. That is population into per capita water demand 50,000 into 150, that is in LPCD or liters per day, by 24 it will be liter per hour. So quite obviously Q design will be 75 into 10 to the power 5 by 24 liters per hour. Here ROF is provided. ROF is provided here as 180 liter per hour per meter square. So from here you can go for surface area, which will be Q by Q design by ROF. Here we have forgotten to multiply 1.8. So it's 1.8 into 75 into 10 to the power 5 by 24 into 180. That will be your surface area. It's 3125 meter square. L is to be 2 is to 1. So 2b square is equals to 3125. No, sorry. It is the total surface area, right? So area of one filter we need to find out first. Extremely sorry. I missed it in hurry. Area of one filter, it's 3125 by 5. Why by 5? Out of 6 unit, 1 is standby already told. That's why by 5. So area of filter is equals to 625 meter square. Area of one filter. So 2b square, now it is 2b square is equal to 625. And from here b will be equal to 17.67 meter. And L is equals to 35.35 meter. So option D will be the correct answer. Question 29, option D will be the correct answer. Hope it is clear to you. Now going for question number 30. Find the number of 20 meter cross. So it's again Q is given as 10 mld. Rate of filtration is 200 liter per hour meter square. So surface area total is 10 into 10 to the power 6 by 24 into 200 meter square. How much it will be? It's 2083.33 meter square. area of one filter, it's 200 meters square. So number of filter 2083.33 by 200. It's 10.41. Anything more than 10 will be 11. Option A will be your correct answer. Option A will be your correct answer. Hope it is clear to you. Option A will be your correct answer. Question number 31. প্রথমে কফিটা করা হয় কেন কালি দিয়ে করাচ্ছিস ওই তো প্রথমে কফিটা করা অ্যাটলিস্ট তাহলেই হবে ওটা পুরো দুবারই ভাগ হবে Now question 31 and 32. A city is going to install the rapid sand filter after the sedimentation tank. Use the following data. So design loading rate is given. Q is 200 meter cube per meter square day. It's again mistaken. It's ROF. Q is 0.5 meter cube per second. So total surface area required will be Q by ROF. You need to very careful about the unit. ध्यान देना पड़ेगा आपका 0.5 meter cube per second into 24 into 3600 by 200 meter square. It will be 216 meter square. Option C will be the correct answer. For 32, area of one filter is 50 meter square. So number of filter 216 by 50, it will be 4.32, but anything more than 4 will be 5. Now the question is, as it is, so as it is rapid sand filter, we need to take one unit as standby. That's important. So final answer will be 5 plus 1 at 6. So 6 will be your final answer. Option C. 6 will be your final answer. So आपको अगर ये 32 क्वेश्चन के सिवाय और भी कुछ क्वेश्चंस हैं फिल्ट्रेशन का that will also solve tomorrow's class before going to the filtration problem. So just have a look through the questions solved. Coagulation, flocculation. For filtration. So these are the batches launched for general studies target AC prelims. Don't forget to apply the code SEN10 ACN10. That will help you to get the 10% discount directly. Also remember that if you don't have the Unacademy Learning app, install it right now. In the description box, you can get all the launched batches details and their links. Install it and go for the plus courses. You will get the topmost educators classes. And don't forget to apply the code SEN10. Subscribe it right now. Don't be late. Be early. Be smart for your preparation. And go for the dream. Let's crack it. Thank you for today. We'll meet tomorrow for further questions and answer discussion. Goodbye.